Welcome back from your break. I hope you had a great one. You're well rested and ready to hit the ground running. Today is the 28th, and we are going to continue with our systems of equations. On Friday, you watched a video on word problems, and then you completed the back of 14. Okay, remember it was the page that looked like this. We used a couple of these, and then you guys got down to number 5, and you were like, wait a minute, this looks a little bit different. And I told some of you to try to figure it out, and that this is what we would talk about today. So this is a different type of word problem. Okay, so we're going to start with this one in our notes. So have this out, and in your composition books, open up your page, open it up, and let's just do a title of word problems. And you can go ahead and say back of 14, number 5. And that way we'll do the work here and do not rewrite the problem. So it says a customer bought 5 pounds of mango and papaya for $37.75. How many pounds of each fruit did the customer buy? So you're looking for how many pounds of each. So that defines your variable for you. Okay, so I'm going to let x equal the number of pounds of, and the first one, as I told you, I always label x my first one, the number of pounds of mango. Y is number of pounds of papaya. Okay, so that's what we're looking for, is the pounds. How many pounds of each did we buy? Well, what do we know? We bought 5 pounds total. Okay, so 5 pounds total of fruit. Well, you have to think about what does the fruit consist of in this problem? Mangoes and papaya. So our first equation is x plus y has to equal 5. Okay, I bought 5 pounds. The pounds of mango plus the pounds of papaya have to equal 5. Now, our second question is, or second part of it says we bought 5 pounds and we paid $37.75 for these 5 pounds. So what do I know? Now I'm talking about money. So now, what do I know x is? X is mango, and how much does each pound of mango cost? $8. And then I know papaya is $7.25, and I didn't leave enough room, so sorry. So now, $8 times the pounds of mango, $7.25 times the pounds of papaya is going to give me $37.75. So now I've got my equations, and I can set them up and solve. Okay, the easiest would be to get rid of x. So I'm going to multiply the the top one, by -8. So that gives me -8x minus 8y is equal to -40. 8x plus 7.25y is equal to 37.75. Remember, you can use a calculator. Okay, so now my x's go away. I have -8 and a positive 7.25. That's going to give me a -0.75y. And then I have -40 and 37.75 is going to give me 2.25, and it is also negative. Divide by -0.75. And I get y is 3. Now, what does that represent? The number of pounds of papaya. And think about it. Does that make sense? First of all, if you wound up getting a negative, you can't have negative pounds. So therefore, you know you did it correctly. So if y is 3, then obviously x has to be 2. So your answer is 2 pounds of mango and 3 pounds, make sure you label, of papaya. Sorry, can't spell here. Now, you didn't have to write the mango and the papaya because you've already identified your variables, but you do have to have pounds there. Okay? Now, I had asked you to pick up this worksheet. It's not labeled. It says Practice C, and it says 131 at the bottom. Okay? And we're going to do number 10. Okay? Number 10 says the sum of two numbers is 39. The greater number is 5 less than 3 times the smaller number. What are the two numbers? Okay. So now, this is page 131, number 10. And I'm talking about two different numbers. Okay, it says the sum of two numbers is 39. So I need to identify x is going to be the bigger number. Y is going to be the smaller number. Okay, so the sum of these is 39. So x plus y is equal to 39. Then it says the greater number is 5 less than 3 times the smaller number. The greater number is x, so the greater number is 5 less than 3 times, so 3 times the smaller, minus 5, because remember, when it says less than, you reverse the order. Now, common sense, what method should you use? I would use substitution. Take this and substitute it in, and you get 3y minus 5 plus y is 39. Collect like terms. Be careful, that's 3 and a positive 1 gives you 4y minus 5. So 4y is equal to 44. So y is 11. And here, if y is 11, then we know x plus 11 is equal to 39. So x has to be 25. And then you could go back in and check it to make sure it works. Okay, let's do number 11 on that same page. It says Adam has dimes and quarters in his pocket. There are 28 coins in all, and they are worth $4.60 altogether. How many quarters does Adam have? So I'm looking for how many. So the number of quarters and the number of dimes. Actually, here it says how many quarters, but obviously you need to find out the number of dimes as well. Okay, so what am I going to do? Define your variable, and I'm looking for the number of, and I read dimes first, so number of dimes, number of quarters. Okay, so I have 28 total in my pocket. So x plus y is equal to 28. Then what do I have? I know I have $4.60 of this. Well, we have to fill in the blanks. So if you're thinking about total amount, how much is each dime worth? And you should have said 10 cents. How much is each quarter? 25 cents. Okay, so if I multiply everything, I'm going to get rid of my dimes by a negative 0.10. You get negative 0.10x minus 0.10y is negative 2.8. Then rewrite this. X's go away. Negative 10 and a positive negative 0.10 and a positive 0.25 is 0.15. Negative 2.8 and 4.6 is 1.8. Now what do? I divide. So y is equal to 12. So if y is 12, x plus 12 is equal to 28. X is equal to 16. So what do I have? 16 dimes and 12 quarters. Okay. Okay, next. Okay. So far there were 3 examples for word problems for you. Draw a little squiggly, and let's talk about some special systems. We've already talked about these as far as graphing, but now we want to see, okay, what do they look like if I'm just giving you the equations and you have to solve? Okay, we know that a system of equations can have 3 different solutions. I can graph them and I can get 2 lines that intersect, which results in one solution, which is what we've been doing, okay, where we solve them and we get one answer. Then we know we can graph 2 lines and they do not intersect, they are parallel, they will not have any solutions, so no solution, because they're parallel. And then we know that we can graph two linear equations, and they end up being coincidental lines, so they have infinitely many solutions. So how does that look if I'm not graphing and if I ask you just to solve them? Okay, well, the one solution, as I said, we've already done. So let's look at this example. If I give you negative 6x plus 2y is equal to 4, and negative 9x plus 3y is equal to 12. Okay, we're just going to solve this. So I want to get rid of y, so I'm going to multiply the top by negative 3 and the bottom by 2. And remember, one of them has to be negative, and I chose the top. It doesn't really matter. Distribute, and then distribute here. Okay, so I'm getting rid of y, and we know a negative 6 and a positive 6 is 0. So now 18 and negative 18, well, that goes away also. So what am I left with over here? A big 0. What am I left with over here? A negative 12 and a positive 24 is 12. When does 0 equal 12? Never. So no solution, which means these two are parallel. Which means, as you know, if they're parallel, when you write these in slope-intercept form, they will have the same slope. Okay, so that's what a no-solution system of equations looks like when you solve it. Okay. So here I want to get rid of y, because I see this is a 1, this is a negative 3. So I'm going to multiply the top by 3. So I distribute, and I get 6x plus 3y is equal to 15. Bring this over. Negative 6x minus 3y is equal to negative 15. So what do? I got rid of y. And now 6 and negative 6, well, again, that goes away. So what do I have on this side? 0. What is 15 and a negative 15? Also 0. So when does 0 equal 0? All the time. So all solutions. So infinitely many solutions, which means these are coincidental lines. And if you look, they are the same. Obviously, this one is just the opposite of all this. So I can factor out a negative 1, and it would be the exact same. So that's what the special systems look like. Again, you can have no solution, which means they're parallel, and you would get an answer that looks like that. Then you have infinitely many solutions, which means they're coincidental, which your solution would look like this. And then obviously the third one is one solution, which again goes back to what we've been doing. When you solve it, you literally get one answer. Okay? Okay, now you can start on your homework. Hope you guys have a great night, and make sure you are ready for your AF tomorrow.